Pas si ça c'est de où tu peux s'arranger. Ouais. Welcome back. So welcome back for a very promising afternoon of discussion. And thanks again to our sponsors and their support. And now I'm really happy to introduce Stephen Hanson. Stephen is a former Royal Canada Air Force, presently a member of the NATO headquartered international staff. He is working at Aerospace Planning, Security and Policy for the Armament and the Aerospace Capability Directorate in the Defense Investment Division. Stephen has played a very instrumental role in the development and the signing of our technical cooperation agreement between EUROCAE and NATO that we signed last June. In this talk, he will highlight the importance of collaboration between civilian and military aviation community to develop the best standards and the value of dual-use standards. So thank you.
Thank you. Bonjour tout le monde. Good morning, good afternoon, everyone. I hope I didn't wake you up after that wonderful meal. Thank you very much to EUROCAE and to our hosts for the event. The food was awesome. I have a weakness for Spanish food, especially when there's going to be more tonight, so looking forward to that too. Just a slight change. Yes, I did do aerospace planning for about 6 years in NATO headquarters. I actually moved roles since the TCA was assigned. I'm still working with EUROCAE on standards, but I'm also doing it from an interoperability and standardization point of view from land, air, sea, digital, and space, which is really quite interesting because I did 32 years in the Air Force plus 6 years, so 38 years focusing on aviation, and just realizing how much of standardization is cross-domain is really, really important. So it really is my honor and my privilege to speak to you today about the military and civil collaboration in standardization, which I personally think is a critical topic. It really affects the future of aviation, and we have to focus on safety, efficiency, and innovation within the aviation field. During my 15 minutes of fame, I'm going to try to focus on the importance of collaboration and standardization efforts, the value of dual-use standards, and how the military and civilian aviation communities can work together to establish common standards that benefit both sectors. First of all, as we all know, military and civil aviation operates in a highly regulated, safety-critical environment where the margin for error is razor thin, specifically when you're talking about fighter jets and the amount of traffic around a lot of the European airports. As a result, standards are essential, but these standards should not exist in silos, or if some of you spoke to me today, they shouldn't be on their own little islands of excellence. They need to be connected. The potential for collaboration between military and civilian sectors is vast, whether for design, technology, safety protocols, or operational procedures. The vast potential for collaboration in aviation should fill us with optimism about the future of our industry. And now, working in a multi-domain environment, I've seen that collaboration is not just in aviation, but across all the domains that we work in. So talk to your friends who run railway, talk to maritime, talk to space. I think we all have something to learn from each other in the area of standardization. Because really, by uniting our efforts, we can achieve better, more universally applicable standards that ensure safety, promote innovation, and streamline development processes. I've heard that word innovation, I've heard that word streamline and safety a lot this morning, and I'm really happy to hear that. So first, let's examine why collaboration is beneficial and essential in standardization efforts, especially in aviation. The potential benefits are numerous, from enhanced safety and efficiency to cost savings and innovation. However, the risks of not collaborating are equally significant, including possible safety hazards, increased costs, and slower innovation. In any complex system like aviation, we often face different priorities, and I think one of our RTCA rep mentioned that earlier in the last panel. Priorities are changing, and not everyone in the aviation environment, whether it be military, civilian, or just in civilian side, always have the same priorities. Civil aviation, primarily driven by commercial imperatives, and regulatory bodies like EASA must focus on safety, efficiency, and customer experience. On the other hand, military aviation prioritizes defense requirements, information security, and mission success, which in some cases is very simple. It's moving people and equipment from point A to point B. In other cases, it's very, very kinetic, very explosive. These differences may create a natural divide in how standards are developed, but we must understand that many of these same principles, safety, reliability, and interoperability, underpin both of these sectors. By working together, military and civilian aviation can benefit from the shared knowledge, expertise, and resources each industry brings. This collaboration can reduce redundancies, ensure better resources, and promote the creation of more robust standards and with broader applications. Take, for example, the development of avionics and air traffic management systems. Historically, military systems were developed separately from civilian ones, sometimes with incompatible technology, making integration and interoperability very, very difficult. However, in recent years, the military and civilian sectors have begun to collaborate more closely on communication, navigation, and surveillance standards, and we'll talk about that in a little while. The result is better interoperability between military and civilian aviation assets, and more efficiency and cost-effective systems that benefit both sectors. GNSS, created for a purely military reason at first, now the backbone of more than just aviation, our finances and many other things. This brings us to the dual-use standards, an idea that has become increasingly vital as technology and global dynamics evolve. As most of you know, dual-use standards refer to those standards that can be applied to both military and civilian domains. They are designed to be flexible enough to be adapted for either sector, ensuring that the systems and technologies created can serve multiple purposes. One of the most compelling reasons for establishing dual-use standards is the accelerated pace of technological development. In today's rapidly evolving world, new technologies are being developed faster than ever, and we see that regularly in NATO from our programs like Diana and things like that, but also we're seeing that also in the civilian sector. By creating standards that can be applied across both military and civilian sectors, we reduce the redundancy of having separate efforts in standardization for both industries. This can lead to faster deployment, more agile development cycles, and overall cost savings. The reassurance of these benefits could instill confidence in the aviation industry's efficiency and cost effectiveness. For example, shared research and development initiatives can lead to faster deployment, and basically the idea, if we can do the research together and start the standardization together, we get the product out faster, we get a better use, and then we know how we can use it across the two organizations. Additionally, when we look at the advancements in unmanned aerial systems, or drones, it's clear that the same underlying technology used for military reconnaissance and surveillance missions is now being adapted for civilian use, such as search and rescue, environmental monitoring, or product delivery. By adopting dual-use standards, we ensure these technologies can be shared between both sectors, leading to quicker development and operational flexibility. Furthermore, when the military and civilian sectors agree on common standards, they can focus more on innovation rather than reinventing the wheel with every new system that comes across the table. So how can the military and civilian aviation communities work together to create common standards? The good news is that there has already been some successful examples, such as collaboration in the United States between the FAA and the United States Air Force on projects such as Metge and other systems. Several frameworks exist that we can build upon to make this process more seamless and effortless. The first I'd like to cover is really collaborative efforts. It's the best way to foster collaboration and is by creating joint task force and working groups that include representatives of the military and civilian aviation communities. These groups can be platforms for sharing best practices, aligning goals, and establishing the parameters for developing common standards. By participating in such joint task force or working groups, each one of you can play a crucial role in shaping the future of aviation standardization for the military and the civilian industries. For example, NATO and EUROCAE have signed a collaborative technical agreement under which both organizations can participate, when invited, in the other standards development activities. While the two groups initially began discussing collaboration in air traffic management and communication, navigation, and surveillance technologies, conversations have expanded into airworthiness and uncrewed systems. If you not know, most armed forces worldwide have an airworthiness program that usually equates to their civilian equivalent, national equivalent. And most defense and security-based aircraft operate extensively during peacetime, sometimes in crisis, and very rarely in conflict. To guarantee that military aircraft are available for defense and security needs and operate safely among civilian aircraft daily, allies and NATO take airworthiness very seriously. This is a North Atlantic Council approved program where we actually look at the airworthiness of all the allies and partners, and we make sure this is a critical information provided to senior leaders to understand the risks that could be involved when mixing military and civilian aircraft in operations. Some specific concepts of collaboration between NATO and EUROCAE have been suggested, and they're already working on these programs. One is to study how to accelerate airworthiness processes, which would allow for or consider rapid changes in the operational environment. So now when we do airworthiness for aircraft, we think of their operating environment. We want to improve the process to say, okay, airframe A is airworthy in this environment, in this situation. Will that same airframe be also as airworthy in this new environment that changes from Sahara Desert to the Antarctic? We also are looking at studies on how to modify airworthiness processes so they can support the rapid adoption of new equipment or aircraft modifications or technologies. This is of value to all aviation communities. We've had problems in the past in the military where we have an airframe which is very good at doing one very specific mission, but that mission has become much less important. And a crisis happens and we need to add new equipment to this airplane. And yes, we need to go through the airworthiness process and to work with EUROCAE and the experts in this room and beyond to help improve the processes to be able to modify airplanes rapidly and do the airworthiness testing required or verification required is critical, and that's a value also, we believe, for the civilian market. Also, we're looking at improving the airworthiness and management of crewed and uncrewed aviation systems during peace, crisis, and conflict, and the release of, I think it's part 4 of Annex 6 of the ICAO. You know, we have now more and more documentation coming about the world of UASs, and so that we can learn from each other and how to improve our airworthiness and our systems integration for this is important. I am sure that NATO and EUROCAE's collaboration will lead to advancements in European aviation safety and efficiency. And additionally, I believe that the collaborations such as this will enhance the exchange of knowledge and experience between the military and civilian aviation experts and communities. By participating in such agreements, military and civil aviation entities can contribute to developing international standards that benefit all. This policy alignment is crucial for the future of aviation, ensuring a secure and efficient industry for all. The concept of working with standards developing organizations, civilian and industry-based, is actually being pushed by the North Atlantic Council, the 32 allies. They see this as the way forward for standardization for NATO. Another practical approach, because that was my first one, is shared R&D. The example I like to use on this of research and development is in NATO we have a group called the NATO Industrial Advisory Group. We have over 5,000 industries represented through 32 different associations at NATO headquarters who meet, and they try to advise NATO on what directions, and we have questions about industry and things like that. One of these groups, they've started up a study group 308. It is the study group focused on the future of aeronautical navigation, not just for military, not just for civilian, aeronautical navigation for manned, unmanned, or aerial systems. This group presently has, last time I checked, 58 representatives of industry who are coming together with NATO experts to look at where the future capabilities, and one of the key factors in this study group is because I may have be part of the group that presented the idea, is that they consider standardization as they look at new concepts and technologies. What is already available? What can we do together? What kind of standards do we need to have, whether it be technical, material, procedures, and things. So it's really important. So we start that R&D together, having the standardization question in our head already, and as the technologies come out, we have a way forward already that both the military, defense and security, and civilian aviation environment agrees on. The third key thing we need to do is we need to break down the walls on data sharing and transparency. We talked about this earlier among companies. You know, why should I share information with you? What have you done for me? And it's a military thing. We don't want to share information with anybody. We classify everything. We even have a NATO classification that is called NATO unclassified. That gives you how bad it is. So we have to break down this wall. It's a key barrier to successful collaboration. And like I said, our tendency for industry, when it's questions of making money, and defense and security, because we are anal retentive sometimes, you can quote me, is to compartmentalize data and information. To truly align on standards, both sectors must engage in transparent data sharing practices. This means establishing secure communication channels where technical data, safety, incident reports, performance metrics can be exchanged freely. Obviously, there will always be some kind of limitation that's expected, but we should open the doors as much as possible and share. This kind of communication fosters trust between the two sectors, allowing for real-time problem solving, and helps ensure that the standards developed are comprehensive and practical. Finally, we need to have a collaboration. We need a collaboration environment that requires firm policy and regulatory alignment. We need to focus on that kind of view. The governments, international organizations, and regulatory bodies are crucial in setting and enforcing standards for the civilian environment. By aligning the regulatory frameworks for the military and civilian aviation industry, we can create a unified approach to standardization that avoids the fragmentation and often arises from disparities in policies. In some countries, the standardization of the military and the standardization of the civilian is very well aligned, similar to airworthiness and other processes. In some countries, it is not aligned. They're very, very separate. There needs to be an effort on both sides to try to line themselves up, to work together, to get together in those meetings and say, okay, this is how we're doing standardization in aviation this is our policy, this is our regulatory framework, this is why we're doing it, and the military to at least understand and try to build systems or processes that support that, and vice versa. The civilian side needs to understand why the military has certain processes in place, the policies and the framework, in order to help them better understand where we can find common ground. For example, the U.S. Department of Defense and the FAA have collaborated on several key initiatives to integrate military civilian airspace and ensure both organizations operate compatibly using proper safety and based on standards. Having been on exchange with the U.S. Air Force, I saw that firsthand, where standards were applied, we worked well together, and we got things done because we used common policy, common framework, and we understood the importance at certain times of using common standards. A similar approach to standardization can be applied in other areas of aviation technology, such as cybersecurity and artificial intelligence. In conclusion, the importance of collaboration and standardization efforts cannot be overstated. By working together, the military and civilian aviation communities can develop common standards that enhance safety, reduce costs, and promote innovation. Creating dual-use standards is a key avenue through which both sectors can leverage each other's strengths, ensuring that technologies and systems can be seamlessly integrated. Let's remember that it's not just about working together, it's about the transformative power of collaboration in shaping the future of aviation. Aviation is a domain that crosses all borders. You can't get to space without going through airspace. That was my joke. And boats, guess what? You need the air for the engines. Just a joke. But aviation is critical. We cover the world. And we are so, it's the best place if we can start showing proper collaboration between the military and civilian in these domains. We hopefully can influence more collaboration in other domains also. So as technology advances, the need for common standards will only grow. By establishing these joint task force or working groups investing in shared research and development, improving our data transparency, breaking down those walls, and aligning our regulatory frameworks and policies so we can work together. We can build a safer and more efficient and more innovative aviation ecosystem. And through continued collaboration, we can shape an aviation future that benefits everyone, whether it's in the skies over our cities or on the front lines for the defense of our countries. So thank you very much. I deviated from my notes, so it's going to be on YouTube now, so I got to wear it, that one. So have a great day. Thanks.
Thank you very much, Stephen, for sharing these very powerful examples with us on how we can benefit from this collaboration, civil-military, in both directions. And indeed, the cooperation agreement we signed with NATO last summer should really help us in terms of coordinating between the different working groups, going quite a long way. Before moving to the next panel and an afternoon which will be dedicated to AI, we have a message from our gold sponsor, Airbus, which I would like to share with you.
Good afternoon, everyone. So I'm Tuk. I'm from EUROCAE. When we're talking about AI, we're talking about the most advanced technologies and influencers of our times. And it's touching any corners of life. And in aviation, we raise important questions on how will AI and human can collaborate efficiently and safely. And also how far can advanced automations can really go in the coming times. So to get the response from the different views, so I please welcome you to the panel 2, Human AI Teaming, where we're talking about the readiness and preparation of the industries. So please welcome on board our moderator, Renée. So she has over 20 years experience in aviation and also the project managers of Human AI Teaming at EASA. So I please welcome Renée.
Thank you very much, Tuk, for the introduction. Thank you very much, EUROCAE, for inviting me to moderate the panel on human AI teaming. And I would like to introduce the panelists from the industry. So we have on the panel a variety from industry, supplier, manufacturer, and ANSP. So we have Adrien Metge. Adrien works at Collins Aerospace as a senior research engineer within the autonomous systems team, where he contributes to the development of collaborative autonomy solutions. Then we have Gary Brown. from Airbus. He gets solid experience in many platforms from A400M, Beluga XL, and so on, and he covers all Airbus commercial aircraft as the safety approver for all systems at Airbus Filton, UK, but also here in Madrid. And he is also part of the working group 114 and secretary of G34. We have Corinne Gingins from Skyguide. She has been working for Skyguide for the last 20 years, where she has developed a wide practical experience in safety and compliance, both as a manager and as an engineer. She's a member of the International Joint Committee for AI in Aviation, also under this role part of the Working Group 114, and also of the rulemaking task 0742 at EASA. She also leads a multidisciplinary group of experts at Skyguide that explore AI opportunities and potential impacts. And then we have Gernot Konrad from Honeywell. Dr. Gernot Konrad is the Chief Engineer for Human Factors at Honeywell Aerospace Technologies, where he provides leadership and vision for human factors across multiple avionic platforms. So these are the experts that you will hear discussing and talking and presenting in the next hour. But first, as human AI teaming is the topic of the panel, I would like to set the scene. What's the hook for the human AI teaming concept? And for that, I need the slides. Also, please scan the QR code. After the presentation of the panelists, we would like to receive your questions and answer your questions. No. Okay, so EASA has written a document that's called, what we call the concept paper. So you see here on top the roadmap, and we had a concept paper proposal issue 1 and the concept paper issue 2. So where we explored and wrote the first guidance. And then in the concept paper issue 2, we actually described the concept of human AI teaming. And at the moment, we are working on issue 3, where we go beyond into level, what we call level AI level 3. So these are the AI levels that I'm sure you have heard of. So there are 6 AI levels that were developed in this concept paper, and they start from automation for information acquisition via analysis and then support to decision making. So here we are talking about AI level 1, and then we are talking about level 2, where we have directed decision and automatic action implementation, and supervised automatic decision and action implementation. And this is AI level 2A and B. We talk here about the human AI teaming concept. So this is where the human AI teaming concept kicks in. And then we are not there yet, but we are working at the moment on the development of AI level 3A, and at a later stage then for level 3B as well, what we call advanced automation. So the human AI teaming concept, level 2A and level 2B, we use the term cooperation and collaboration to differentiate between the 2 levels. In the level 2A, we still talk about something what we call the full authority of the end user. We are talking about the end user situation awareness, and it's the goal of the end user, whereas in 2B, we are talking of the shared situation awareness, so the AI-based system has to have the same picture as the end user, and they're working towards a common goal. And in this level 2B, we have communication that's going back and forward between the 2, the human end user and the AI-based system. So this is the human AI teaming concept, and we would like now to hear from the industry what examples they use to apply it, or in which technologies they apply it. But it's not only that we are showing solution in this panel. You will hear the panelists have a lot of questions themselves that they are dealing with every day. Maybe you have some answers for them in the coffee break, or even in Slido, you can provide us with the answers. Adrien, please.
Thank you, Renée. Good afternoon, everyone. I'm happy to be part of this panel. So I want to start our small presentations by talking from a research perspective. As human AI teaming is a hot topic, we all have different representation of what that means, but concretely, what kind of use cases could be enabled through human AI teaming? So I will talk about the example of a CESAR research project. So firstly, you may have noticed that what we were called previously in the last decades human system interaction is nowadays more called human AI or human autonomy teaming. And I think this evolution from interaction to teaming is not just a semantic detail, but is actually very meaningful as we are considering autonomy and AI not only as a tool, but maybe as a kind of technology that can really assist the pilot in a more meaningful way, as it could maybe have a representation of the pilot need, and so being, in a way, more intelligent. But concretely, what does that mean? And how could we have a human-centered design approach that could really use this AI-enabled system to be at the service of the pilot, of the operators, of the ATC controller? To make the link with this morning presentations on CESAR initiative, I can mention quickly the CESAR 3 Response project, which is a European collaboration with many partners in the industry. Response standing for Reduced or Single Pilot Operation Incapacitation Safety Enhancement, which is an exploratory project where we investigate how a digital assistant could try to measure the physiological state of a pilot, or maybe used behavioral cues to have a representation of this pilot state, and based on that, maybe to have a different response to really be sure to be adapted to the pilot need at a given moment. Do we already have the technological bricks to do that? Is it something that can have side effects? This is a kind of research that is being conducted at the moment. The use case in the response context that we are working on is the pilot incapacitation, either completely or partially. For example, if a pilot can have a very high workload, the question is, could the system firstly detect an excess of workload and then act as a kind of a virtual teammate to maybe take a more important part of the work and coordinate with other assets? So really adapting to the need of the operator of the pilot. So as a few food for thought for you, I have listed a few research questions that, in my opinion, are very representative on how human factors may be the key element on enabling human AI teaming. For example, how do we effectively measure and build appropriate trust in human AI teaming? How can we design AI systems that explain their reasoning in time-critical situations? And finally, to make the link with the next presentation, what new regulatory frameworks are needed for systems where responsibility is shared? Thank you.
Thank you, Adrien. Gary?
Okay.
Thank you.
Okay. Are we in? Okay, so leaning on what Renée said and coming from the perspective of the EASA concept paper, I'd like to provide some viewpoint. So if we think about AI human teaming and what EASA intent is in our concept paper, we have level 2 considerations that we want to debate and understand. So they talk about the end user. If we think of the end user as the human will need to understand the AI machine role. What is the role of both the end user and the machine? So is the machine the helper, or is the machine the team player? What is the mission goal that they're both participating in? What are the tasks allocated? And more importantly, what is the function that we're trying to do? What is the success or failure of this function? If we understand this, then we can look at the risks. We have already seen a level 1 appreciation of assistant. At level 1B assistant, there's a very low cost burden or expectations from the EASA concept paper in terms of anticipated mocks. But when you enter the domain of level 2 as an AI teaming, this will escalate. Now, it doesn't mean that's a bad thing, because I'm a very big believer in AI if used wisely. It can reap huge benefits for safety, for the environment, and many other outcomes. But we have to think about reliance. Once we introduce this new tool in our toolbox, we have to be careful of over-reliance, because the human, or the end user, can become over-reliant. It can happen. And then there's the hidden failure that can come from the machine. So we need to be careful when we enter the concept of level 2A, which is cooperation, as the entry point. And then we go into a more, I would say, indulging sharing, which is co-sharing, in 2B. So it's important to establish the use function with the authority and internally at your OEM, and the end user reliance placed. So if you want to get a modification approved, you have to think about this, and you have to think about the overtime. Is it still going to be able to do the same job in 2 years, 3 years? Because, you know, we have certain problems with AI that need to be understood. Then when we think about the manpower, we have to make sure we put in place the necessary training, not just of engineers. We have to understand the skills. We have to understand the qualifications. So we got them. Each OEM needs to put in place these, as well as the regulator needs to understand and direct. So we have the end user. They have safety where I work. You know, we have to upskill the safety engineers because they need to understand the moving goalposts. Human factors are fundamental when we're in level 2. Software and complex hardware assurance nominees, maybe we need to now have a neural network or a machine learning nominee. Security, we need to be careful about attacks against the functions that are using ML. The design, obviously, design engineers, certification and airworthiness players, and program. And then we have the new player on the street. We have a data scientist. They're the new addition. They will work with the design teams and the safety. So, looking at the real-world experiences, so what we do know today at an OEM perspective is, looking at the EASA concept paper, there is a cost burden. But of course, there's a return on RTO by using ML functions at an OEM. But these will grow exponentially with team leveling agreement. So when you go into level 2A, you have to understand there will be a cost. And in 2B, that cost will rise exponentially. You need validation with the authority on the worst case safety scenario or scenarios, i.e. the bad behavior of the machine. What if it tells a lie and you don't know it's lying? You have to understand its participation, what it is doing with the end user. What's the shared goals? When you do agree and you secure the assurance level, i.e. the integrity that you're going to build it with, which is the standard that I'm working towards, ARP 693 and ED 324. You need to then discuss about the AI levels. But when you finish that, then you need to go to the EASA concept paper and look at the objectives, of which there are many, 129 objectives. Now, when you go into team leveling, these new objectives become apparent, especially at explainability and human factors itself. So there's a lot of additional objectives. They are satisfied by anticipated mocks, so they're open to discussion. And this is what we need to talk about. When we are, as an OEM, trying to move forward with an ML function, we're trying to get approval, we're trying to get a way forward to secure the implementation, we need to look at the objectives in 4 ways. 1, we can do acceptance in full, right? So we can satisfy the anticipated mocks. Or 2, we can do it partially. Or 3, we can reject it. Or 4, we can elect to move higher. So the last point is the work in progress, which is the ARP 6983 and the ED 324. At the moment, it doesn't consider human factors. Okay, it's out of scope. Thank you.
Thank you, Gary. Corinne?
Thank you.
See the ANSP view now from Corinne.
Alors. Est-ce que ça marche? OK. Good afternoon. So on my side, I would like to share with you our views at Skyguide regarding AI in general and human AI teaming. So as an NSP, we use and we generate large amounts of data. And these data are quite often adhering to quality requirements and standards. So for us, it makes them real good candidates to apply AI and especially machine learning. On the other side, from an operational perspective, we have various functions that could be enhanced with AI. These functions could be implemented standalone with AI. We think, for example, of a trajectory prediction improvement. Some others may be implemented in cooperation between the ATCO and the AI to, for example, identify and resolve conflicts. However, if we want to put some AI in our systems, we want to make sure that these systems will not negatively affect the safety of our services. On the other hand, we also want to make sure that the responsibilities between the AI and the end user, the ATCO, are clearly defined. And for now, we consider that we think that the ATCO needs to stay in command and needs to take the last decision. So, from my point of view, this corresponds to the level 2A in the EASA classification. We also want to avoid the risk of over-reliance, which was already evoked by Gary earlier, because this is most of the time accompanied by the loss of ATCO expertise. Obviously, this is not really good. The regulations and the standards which are being developed address some of these concerns. For example, we have identified additional safety precautions to bring, such as continuous safety monitoring, things like that. But yeah, there is still some work to do there. And one of the challenges also we will face is to balance between the AI and the human in these future systems. How do we prepare to the human AI topic in Skyguide? So by participating to the development of the standards on, it was mentioned earlier, the work group 114, the EUROCAE work group 114, which aims at developing standards for systems embedding AI. Internally, we have put in place a multidisciplinary team which aims, amongst others, at identifying the impacts of the EASA concept paper and to, identifying the impacts on our organization as a whole, our processes, the training, and so on. We have in place already since a long time a human factor team which has elaborated an automation concept where they actually reaffirm the centricity of the ATCO. And by prototyping with our subsidiary Skysoft, we try to find out to address the concrete limitations and advantages of using AI. And the ATCO is involved in all of these initiatives. Regarding the impacts, most of them have been already mentioned. The fact that the costs will increase to develop these AI-based solutions. The fact also that we will have to evolve the training of the development teams, but also probably of the ATCO. And we will have to face both over-reliance, but also lack of trust. So we will have to find a solid argument to convince the ATCO on one side, but on the other side, to avoid over-reliance on these tools. To summarize, actually, so we all know that safety is at the heart of our activities. Our systems for now remain human-centric, and we continue to explore the advantages and limitations of AI, and specifically human AI teaming. Thank you.
Thank you very much, Corinne. Thank you. And then we come to Gernot from Honeywell, who has a lot of questions.
I know. First question is how to operate this remote control. Okay, Renée warned you already about, so I would like to start with actually questions in my presentation. The question would be, can we actually use artificial intelligence to do the work of human factors practitioners in design, analysis, test, and certification of flight decks? And can AI produce human factors, artifacts of reasonable quality? And if so, what processes must be in place to make AI-created HF artifacts acceptable for compliance demonstration? And the reason why I'm asking that question is because the industry in general, and the aerospace industry in particular, is really having a challenge of hiring qualified human factors practitioners. And this has led to a workforce shortage. And the question would be, can artificial intelligence help us to close that gap? So I'm going back to the EASA concept paper and the 3 levels of artificial intelligence. And in an initial way to use artificial intelligence as human factors engineer, if you want to, we could think about the human cognitive assistance in decision and action selection. In the future, maybe human AI-based system cooperation could be provided. So how could that look like on a level 1B AI? Could support decision-making, development of particular artificial intelligence-created artifacts based on expert inquiries. But all authority would still remain with the human, and no autonomous execution of actions by the artificial intelligence. Whereas on level 2A for AI may already automatically structure and plan human factors work under human oversight. What are the boundaries of AI-augmented human factors engineering? Well, first, we would need to answer the question of what are the tasks that would be best suited for artificial intelligence, and where will human judgment remain irreplaceable? And the answer we may find at the end would be that maybe a hybrid cooperation where AI and human experts together outperform pure human or pure artificial intelligence performance. And all this, of course, comes with questions around accountability, safety, and, of course, legal aspects as well. So question to the authorities would be, if we really use artificial intelligence to generate especially certification artifacts, in what way do they need to be marked or clearly identified as being generated by artificial intelligence? And what should a human-machine interface look like for human experts to review effectively the work generated by artificial intelligence? How to properly support humans for AI cooperation and supervision is another question, and obviously how to address pressing issues with automation bias, authority bias, confirmation bias, optimism bias, status quo bias, and also sunk cost fallacy. Well, in the EASA roadmap, there is this EASA trustworthy AI building blocks. If you think about AI assurance, we need to make sure that we maintain transparency. So what has been created by artificial intelligence, and how can we mitigate hallucinations? And also ensuring proper data was used for training the artificial intelligence. In terms of human factors for AI, we need to ensure we have efficient human-machine interfaces for prompting and allowing effective review of experts of the AI-created work. And transparency is a high priority, highlighting AI-generated data. Clear role definition must be in place, whether level 1 or level 2 AI is used. And AI safety risk mitigation must be addressed as well. We need to prevent incorrect content to be used in formal documents. We need to train the users of those AI agents, and obviously there must be some organizational processes in place as well. And for those organizational considerations, of course, it's about skill and training. So what skills can an AI-augmented system actually provide, and what skills must junior human factors engineers develop? And then one of the pressing questions obviously is, because most likely the task in artificial intelligence could take over in the short time, are exactly those tasks the junior engineers are doing today. So how do juniors get actually the experience required to become seniors in the future? AI transparency for authorities. how do we mark AI-generated content and document evolution, and also for the design organization adoptions processes, how can standardized methods be addressed to support EASA design organization adoptions.
Thank you very much, Gernot. Thank you very much. So you heard now from all different domains in the industry, research, suppliers, manufacturers, ANSPs, what we are dealing with. But not only you heard about operational tools that are in the plan, but also, as we just heard from Gernot, tools that could be maybe used for certification. So now we would like to take the questions from the audience, please. So please go ahead. And I have to, okay. Okay, there is one on data quality. I leave it up to the panelists then who would like to take it. Data quality is key to having an AI application give safe answers. What measures are already being taken to develop the data set for training and operations? Is there somebody of you who would like to take the answer, the question?
Okay, I'll take a stab. Of course, data representativity is fundamental in data learning. Otherwise, you train it to do the wrong thing. So, as stated, we're doing a standardization. We're working towards a standard, unified standard with SAE and EUROCAE. This is the ARP 6983 and ED 324 approach. And in there, we provide the necessary guidance and objectives to ensure the DQRs, to make sure that, proportional to the safety risk, that you ensure the necessary evidences, that you have data representativity for the training and the validation. And fundamentally, we have to have an independent data set when you go to the inference testing to make sure on the pass and go, do you allow it to go forward or do you go back to retraining? This is an independent data set that the machine learning tool has never seen before, and it's a kind of test. So yeah, the question posed is correct. Data quality is fundamental and it's built into the standard. So that's your reassurance. Thank you.
Yeah, maybe to complement, we need to have in mind that before thinking of the quality of the data, we need also to, at really, I would say, at a business or operational level, we need to define what the so-called operational domain. And maybe this is something that we don't do, at least on the ATM-INS side, not sufficiently today, and on which we will have to improve so that the data that follow afterwards are, I would say, bounded and are defined in better arrays. I don't know exactly what is the word, but voilà. It's really a whole chain, and we should not only focus on the data, but we should consider what happens before in the elaboration, in the specification part.
Thank you, Corinne. Thank you, Gary. I have another question for Corinne. What is the end goal for using AI in ATC systems? Capacity, increased safety, or something else?
Well, in any case, it's always maintaining at least safety and, if possible, increasing it. Probably capacity as well. Yeah, I don't see any contradiction between the use of AI and maintaining these two objectives, which are already here today. So, yeah.
Thank you. To gain safety confidence, is it necessary to monitor AI systems with classical and mathematical implementations, even if it increases the cost?
Say it again.
I don't know. Sorry. To gain safety confidence, is it necessary to monitor AI systems with classical and mathematical implementations, or even if it increases the cost?
Okay.
I think Gary used cost in the,
Okay, so first of all, we need to talk about the use function. What is the ML doing? And we need to understand our reliance that we place on it. So if we do the safety assessment, functional hazard analysis, and we establish that it's no safety effect, then we don't need to worry about monitoring. If we establish that it has a minor, which is a slight reduction in safety margins, then here I think it's up to the OEM to see whether there's a benefit, whether it's practical, so they may do monitoring for their own needs, but it's not a mandatory, I would say. When you get to a higher safety effect of what's called major, which is a significant reduction in safety margins or functional safety, then there I would promote monitoring. This is something that's in the EASA concept paper. It's looking for monitoring and data recording. And I think it has many advantages. Now, whether you do that with a software solution, I would say is wise, but you could also use ML, so long as it's independent. But it's important to have monitoring and also the data recording. So I would say, yeah, but not necessarily at the low level of minor. I think that's could be considered overkill and should come from the OEM. They want it, not be prescribed.
Thank you. There is a question here on AI applications expected in the cockpit, but I would like to somehow also direct it to Adrien and your presentations. How far are the technical developments? For example, you talked about pilot incapacitation in order to have AI implemented with this goal?
Well, I think there are two different components. If I can look back on the response project, for example, there is the part of having a system that can adapt to a given input that could be, for example, the pilot state or behavior, which is kind of feasible, and even with classic automation methodology like expert system. And then there is this question of characterizing the pilot state, being able to build a kind of representation of what they want, of their desires, their intention in a given situation. And that's far more difficult because there is inter-individual variability. A same signal, if we measure physiological state, may mean different things for two different people. And that's the main technical challenge in the moment, in my opinion. So there is a lot of work to do on really human factors at low level, characterizing behavior, understanding, and then the system will be able to adapt on that and really be smarter in this way, teaming.
Thank you. What is the timeline for AI Level 2 applications to be implemented and approved or certified on the flight deck or even the controller HMI? So in the industry, what timeline do you have in mind? There is something about the timeline written in the concept paper, but maybe it has changed by now. So I let the experts from the industry talk.
You first.
Well, I guess the answer of the timeline is difficult. It also depends on, at the end of the day, if you implement something on the flight deck, everything that we put on the flight deck needs to earn its way on the flight deck. We just don't want to put something on the flight deck because it's available. It must have a clear benefit, it must increase safety, and it must have, as I said, maybe reduce the cost for operation or allow for a certain kind of operation that at the moment is not possible. Extended minimas, for example. So if we can achieve this, and if we also have a clear clear path to certification, and then we can talk about bringing something on the flight deck. At the moment, most of the AI applications are in the R&D phase.
Thank you. Anybody else on this? No? Sorry, there was a question, human factors becoming AI factors one of these days. I think we are far not there yet. Also, the EU AI Act, it's clearly stated the human is in the loop, the human is in the center, human-centric AI design or design. Yes, so I don't think we will see that very soon. Does anybody know how you will go to protect the AI system, the AI-based system from hackers? Is this anything you would like to elaborate on?
I think that's a cybersecurity question.
Yeah, I know.
I'm not a cybersecurity expert at all, but I would assume the same cybersecurity requirements would apply then for conventional systems.
Thank you. Then I would like to come back to one of your slides, Gary, where you said we have to upskill the personnel, the staff. So how do you see, for example, the impact on safety assessments and the people that conduct the safety assessments? What will change in their life? What will change in their job with AI?
Okay, so good question. At the moment, it's going very slowly. So if I take traditional safety engineers, certainly they're not aware of or not interested in at the moment on this new implementation coming their way. But, you know, even in my own company, we're making efforts to train internally. So we need the safety engineers to now consider beyond the traditional way, which is we look at random failures in the hardware and we consider software by an assurance level, just like complex hardware. So the standardization fills that gap because the standardization and process for AI ML is now looking to look at data learning and provide an assurance level. If we look at the bigger picture, though, moving forward into the future, it is fundamental for me that we need to move from a design safety assessment approach. So design engineers with safety engineers, we look at it and we try to imagine, like I think it was Carol who said earlier today, we try to imagine that we understand how pilots fly the aircraft. We try to imagine air traffic control. But reality is we need to do an operational safety case. So when we go into level 2 teaming, we start having 2B, which is authority sharing. Yeah, so the machine has a part to play rather than 2A where it does not have any sharing. Here we need to look at an operational safety case with explainability and with human factors. And that is fundamental. If we stay as we are, then it won't be fit for purpose. The typical way of doing our work today is not fit for purpose when we introduce ML technology in the future, because we want to let the machine have a play in authority control. We want to go beyond just an assistant. And yes, level 2 hasn't been implemented yet, but it will be soon enough. So we need to upskill our safety engineers. We need to upskill the end users. As is in my slide, there's a lot of upskilling to do. We need to be ahead of the game because it's coming our way and we can't stop it. Thank you.
Thank you.
Maybe to complement just on what Gary said, regarding safety practitioners, I have the impression that it's, well, monitoring is already there today, of course, and safety monitoring, but I have the impression that this will take more and more importance with when involving AI in our systems, and we maybe need to develop the awareness of the safety practitioners regarding these aspects and what to monitor when, etc., and what to do with the monitoring results. I think this is something that could be injected in the safety methods, I would say. Mm-hmm.
And it's very similar for human factors engineering practitioners as well. It's not only the safety engineers. Mm-hmm. The human factors engineers also have to rethink, because the factors to be considered of pilots working together with an artificial intelligence will be different than the factors that we consider today, pilots working with traditional automated systems.
Thank you. We mentioned before problems of over-reliance. Corinne, how can we make sure that the ATCO can trust the Airbus system?
Trust. For me, it would be based on understanding the decisions of the AI. I know that there are many works done to develop the explainability aspects, but I'm also thinking of other techniques that exist in AI since long, such as declarative AI, where you actually immediately have access to the reasoning, if I can say so, of the AI. So maybe by combining these different techniques, we could improve this explainability, and then step by step, improve also or gain the trust of the users.
Thank you.
I can a bit elaborate on that too. I think trust is not only a metric, but it is an evolving process. when you work with a colleague, you can have a level of trust, and then the more you work with them, you will discover their strengths, their weakness. They may surprise you in good or bad, and I think it will be the same when you will work with an advanced AI system, with a digital assistant. And the more experience you will have with it, the more you will understand what they can do and what they cannot, and you will calibrate and be less able to be over-reliant or under-reliant on their capabilities. So there is also this question of training and getting experience. It can also help.
Thank you. I'm coming to you, Gernot. Again, something you had on your slides. What would be those tasks that are easily transferable from the human to the AI? Which human tasks can be easily done by the AI-based system?
I mean, that's a really good question, and I'm thinking foremost on the very labor-intensive tasks. If you think about today, when we have to show compliance with all the ergonomic aspects, for example, reachability aspects, viewability aspects of the flight deck, we could use computer-aided design, and we can use mannequins, 5th percentile female all the way up to 95th percentile male, and the artificial intelligence could run all the tests that are required to show compliance. Can all these mannequins under all foreseeable conditions reach and see everything in the flight deck? Can all the controls be operated? We also could do AI augmented lighting analysis, for example. We could look into reflections of displays. We could look into glare by using software tools. So I'm thinking about this classic ergonomic aspects first, but then further onwards, even going into more cognitive aspects of human factors, for example, addressing human error analysis, or even preparing flight test plans for workload assessments, for example.
Mm-hmm. Thank you. If we talk about training, Corinne, how do you see the training differ from a training that is now applied for an ATCO system, an automated ATCO system, and then for an AI-based system?
Well, I'm not an expert in training, but I have the impression that somehow the ATCO should have an awareness of what the AI techniques are about, to familiarize them with the way all this works. For me, this is something that could be needed. Otherwise, yeah, they will have to work, to test, yeah.
Thank you. There is another question. Are there any issues of community acceptance going beyond ATCO or pilot? So does the passenger have to be aware that there is AI in the operations included, that there is an AI-based system?
I would say yes, but more generally, it's important they are aware of how the system works, or at least how it can impact their operational use case. They don't exactly have to understand all the parameters and the technical side. But still, AI, I think we need to be a bit careful also, because it's a bit of a buzzword. There is a lot of technique, and if we go a bit more precise and explain what kind of technique they are, how they work, it will help to get accepted also, and to show that just another way to process data, to do calculation.
Thank you. You wanted to? No? Sorry.
Just waiting for the next question.
Sorry. I don't have to check here. Is anybody of you, I don't know, in your company, in your industry, are you looking outside of your domains, what's happening somewhere else in the industry, and you can adopt it into aviation? Or is aviation so advanced that we are further ahead than other domains?
So from my point of view, I can definitely say, yes, we are looking into other domains and we're actually working together with them. And for example, the medical domain where AI is used in diagnosing cancer, for example, from X-rays, that would be a typical example already where you have an artificial intelligence supporting a medical doctor in their decision-making. And this is something similar what we are trying to do in assisting human factors practitioners in flight deck design and analysis as well. So we are trying to learn from what they have already achieved.
Okay.
Definitely.
Thank you.
I think in the automotive industry also, they have been working a lot on human AI teaming and all this intermediate step between I drive my vehicle and it's fully autonomous. The most challenging is actually all this intermediate level. How do you understand what the system is doing when you have to take over, when you have to hand over? How do you manage other vehicles having also these intermediate levels? So there are some work that can be relevant for the aeronautics industry.
Thank you. I can also say from EASA, from our side in the concept paper, the development of the AI-based system, and especially how it is then also listed in the ATM master plan, there is a cooperation that it is linked to other industries so that we really more or less talk all the same language, if you want to call it like that. Is there anything else from your side? I got the signs, so I think we would come to an end of the panel. No? So thank you very much to our panelists from the industry. You saw there is a lot of work going on. We don't have the one and only solution yet. There are still a lot of questions that the different industry partners are dealing with. We know where the issues are. They are from the data input, data quality. It's clearly visible that we need the standards, and what EUROCAE is doing and the colleagues sitting in the working groups is necessary to be able to move ahead, to move forward. There are costs maybe involved, but I guess with a lot of developments there are costs involved, and of course safety is always our first parameter we look at, not to compromise safety. Thank you very much.
Thank you.
Thank you.
Thank you for the very productive panel of human AI teaming. And to following up on that topic, so our next speaker will bring a wealth of experience and very practical experience on the confidence for the operators and end user to enable their possibility to use the AI, especially in the domains of the air traffic controller. So please welcome on stage Marc Baumgartner from iFATCA.
Thank you very much for inviting iFATCA to speak to you this afternoon on what we think is transforming air traffic control with the assistance of artificial intelligence. I would like to invite you for a quiz. I tell you, you can only win my recognition if you can answer the question, okay? But it's maybe... or I offer you a drink later on. Anyhow, during the presentation, I will be asking you if you have identified these two pictures, if you can relate to what they are. And those who raise the hand, don't be shy. We'll then hear or listen if you know. So at iFATCA, iFATCA is the global organization, technical and professional, of air traffic controllers. We represent approximately 30 to 50,000 controllers in over 135 countries around the world. We have always been talking about automation. That has always been something for us which was important because We were working with the tools around, and we were focusing on automation and what is the role of it. This has, however, evolved into digitalization. Machine learning, artificial intelligence, digitalization is not automation for us. It has much more and different kind of potential. So we have organized 4 digitalization conference where we have invited artists, philosophers, researchers, air traffic control representative, regulators, and at the first conference we were invited by EUROCAE to join EUROCAE. And we were so enthusiastic that we asked immediately to create a working group on human factors. Okay, so that we are still we had this request, and we learned that human factors were actually already integrated in a different kind of working groups. We have had last year our last digitalization conference, again with philosophers, university professors, and we presented our guidance material. We call it very bulkily Joint Cognitive Human-Machine System. And we presented that, and actually for us, I will come back as well, we have put that into the public, what we see as issues when it comes to digitalization, modern tools, when introducing into air traffic control. Our basic understanding of digitalization is the following. Some of you might have seen this slide already, but for us it's important to come back. What are we talking about? We're talking about available underlying infrastructures in form of sensors, and that is then covered by a data layer above. That data layer will harvest data, but it will harvest data at a certain amount of data. If it doesn't go beyond that amount, you might not get any of the benefits. So sometimes, and I'm coming back then later on, if each of the ANSPs or if each of the region collects with their digital layer data, you can't get the benefit out if compared to a system where we could have the whole ECAC area, for example, harvesting the same data into the digital layer or via the digital layer into some sort of a big data cloud. Afterwards, you put algorithm in there, machine learning, deterministic, non-deterministic, to be discussed, and with a certain form of artificial intelligence, you mirror, that's one of the functions, you mirror the reality here represented by a Lego tower. Okay, so that's our understanding. Of course, it's not an engineering, it's not a programmer's understanding, but it's our understanding as a user in general concept, what we're actually doing. What we think it will bring, if we are achieving that, is we will be able to reduce the design of infrastructure, the design of also avoiding costly errors in designing and developing new infrastructure. I've used here a tower versus a remote tower, for example, but this digital twin or this infrastructure which could be digitalized has a lot of potential. Maintenance is already something which exists, so you have part of the maintenance of the air navigation service providers' infrastructure being carried out by new technologies, for example here, drones. You can also imagine that you reduce the charging for the infrastructure cost, and then last but not least, something which is very close to our working environment, that you reduce the operational infrastructure costs in the sense that I am able to do, instead of 25 aircraft at any given moment in a 2-level sector, that I can do 40, 50 aircraft, so that you don't need to augment the number of controllers, that you don't need to reduce the size of the airspace in order to cope with the demand of traffic, but actually that you can use the same amount of people, the same amount of current infrastructure, and have assistant, some form of digital assistance. And here you have a few examples. What I haven't put here, but we, as iFATCA, we are now also in 2 CESAR research projects, CODA and AWARE, where we do exactly this. We try to find what is the role of the digital assistants, the AI assistant to the air traffic controller. What function can he take over? What creates the use of such new tools? And that is certainly something which is already transforming our mindsets to learn and identify what kind of assistance we could get. Just to give you again an example from the past where I'm working in Geneva as an air traffic controller and center supervisor. In the past, I had paper strips when I started my career. So I had these paper strips, they helped me cognitively to identify the conflict. Nowadays, I have a midterm conflict detection. I don't have to find out anymore. I don't have to calculate. The machine assists me. Only by introducing that, we were able to increase 30% the capacity we offered. The next step will be to reduce my cognitive workload by actually helping me to solve the conflict. So conflict resolution advisory, in the sense that the machine will tell me, based on what the machine has learned, you could actually solve this issue like this. And that, again, has quite a lot of potential to change my world. So when we have talked and worked on these safety, artificial intelligence and safety critical domain, what we see is it is built on the advances in capacity to collect and store massive amounts of data, significant increases in computing power, and development of increasingly powerful algorithms architecture. And that is a fact of life. So even if it's difficult, you heard it just before, it's difficult, it's challenging, it's a lot of tough work, but that is a fact of life, and that will come to our sector as well. The motivation, we need to minimize delays. We are currently having huge issues with the performance of the overall system. We see also that we will have to open up to new forms of aircraft. We have increased bad weather, which we do not really understand. Is it just climate change? Is it just bad luck? Whatever. And we would like to see smoothing out 4D trajectories and also, of course, reduce the environmental impact. So these are the motivation, not just ours, but also, I think, a general political motivation. What we also always have to say to our members, but also to the outside world, there is a difference between machine learning and artificial intelligence. And it's very important to make the distinction, because once you start to pull out or put out into the sector some of the applications, you will have to understand what you're doing in order to be able to certify, in order to be able to guarantee that the systemic outcome is a positive one and that you are not necessarily surprised by surprises you have never imagined before. So here on one slide, the 5 challenges or the fundamental challenges we have so far identified when implementing artificial intelligence. You heard before also some of the challenges which were mentioned. So I'll go one by one, but before doing that, anybody knows who that is or what that represents? Don't be shy. No? This one, maybe? Okay. We continue then. So, the cognitive system engineering as a principle of design. That is not easy. So you try to use cognitive science, neuroscience, things like this, and that is really not easy. We have now also used in CODA, in the CESAR research project, we have used Hanson model, where you actually try to mimic what's going on in the brain of a human air traffic controller or a pilot. So that, as a principle design, is not an easy approach. The second one I would call the vertical fragmentation AI and machine learning have as a risk or as a hurdle. We see that it doesn't mean the same thing for each of this level when we talk about introducing new technology in our sector. Regulators, governments, business, all these things are not clear. So if you have an ANSP or a manufacturer who develops its own cloud, its own standard, which you can't connect, where you can't connect the data, is basically increasing fragmentation. It will not help anything to improve the potential and actually harvest the potential of this new technology. We still see that. We still see also that some of the business ideas are going actually against what we have already achieved as standards. And that is certainly something where the vertical fragmentation of this new technology is actually a real risk. This I would call the horizontal fragmentation. There is a potential that in order to achieve a TBO or a trajectory-based air traffic control, that you focus on things you can solve with the functionality of the artificial intelligence and machine learning. So you might be able to do very easily, and it's done. In the planning, you might use quite easily, before departure, you might be able to actually come in with artificial intelligence or machine learning program, or you might be able to do airport management with that. But how to connect that from gate to gate, from the pre-planning to the end, that it makes sense, is a real challenge. This is the main slide for me, actually, for my presentation. What we have found out is, how do we keep the ATCO in the loop so that he's able to be aware what's going on and to intervene? What if we have disruption of established pattern in coordinated activity and the resilience? So what if the patterns suddenly do change? Because we are very pattern-like, we are very like in a herd, we follow certain patterns when we do air traffic control. We also fear the instances of AI surprises, because you don't know what you don't know. And the new types of errors, which we do not imagine, and we can't foresee them, we can't simulate them necessarily. This is really something. We think also there will be a demand for new knowledge and skills, and the attention management is something from a human factor point of view we do not really know. New mental models, how do the AI works, how does it fail, why does it fail, how do it adapt? What do I need to know? Do I need to know that, for example, if the wind is above 150 or 180 knots at a certain altitude, the algorithm has not been trained for that? And what do I do then? Do I reduce the capacity? Do I have another tool? Things like this, which are new things which we have to learn. Of course, then there is quite a lot of how the air traffic controller will accept the new role and the remits, the microcultures as well. I'm coming from a multicultural country where we have a different working culture in Zurich than we have in Geneva. So how do you adjust that where the federating element could be the new technology and potentially also de-scaling of air traffic controller? The leftover strategy, we are scared of that, so that in the end you just say, okay, there's a human there, he will fix it. But if I have currently 25 aircrafts, I have been trained in a degraded mode to actually cope with that. If I have 40 or 50 aircraft at the same time, I might not be able to cope with that if the system degrades. And of course, you have then other elements like relocation. So we saw that already when we talked about remote tower. And it could be that some air traffic controls will oppose all this. One of the other challenges we see as a fundamental challenge is liability, accountability. But that should not be seen as the hammer which will be destroying everything. It's really something we think we still have the time to set up an artificial intelligence governance in our sector, which is not existing. This means we have to make sure that those who are programming, that those who are actually managing the infrastructure have a certain amount of accountability. They are accountable for the programming. They are accountable for the result. Otherwise, it's too easy to blame in the end the operator, which was using a machine he was told that it would solve his day or save his day, and that is something we haven't really addressed. So here, also some research which looks into how we could set up some sort of AI governance. So our guidance material is available on the website of iFATCA. It has been written by air traffic controller for air traffic controller, and one of the plea we have, actually, we would like that the technology is there to serve the air traffic controller and that we are not there to serve the air traffic, the technology. That can be then also done by identifying what we really need, because we might not need to automate everything or to have new technology and everything, but certain functionality, certain cognitive task analysis, and we need also to be able to do the project testing. So, what does it mean to be in control in the area of artificial intelligence? How to amplify control within the new range of possibility and technologies, and how can we support effective human AI teaming in the ADC operation? These are questions we are still working on. Now, anyone? Okay. René Descartes. It's the era of enlightenment, and then we finish the presentation. So René Descartes, his daughter Francine died of measles at the age of 5. And he was invited to by the Queen in Sweden to come and present certain things. So he was so in grievance over the loss of his daughter that he had an automat created of her portrait, and that is this automat. He took it along on the ship which brought him to Sweden, and the sailors opened the box where this automat was in. The automat sat up and started to talk to the sailors. So they got scared, threw it overboard. That's actually what is represented here. Here is the digestive duct by Jacques de Vaucanson. I hope I said that correctly. So that duck was seen as a wonder, and many philosophers actually thought that this gentleman was a genius. It ate grains and it digested it, okay? That was a fake afterwards. What do I want to say with that? The human cannot actually not anthropomorphize. It's a complicated word. But what does it mean? We have the tendency to humanize technology. And that sometimes leads us to be too enthusiastic and becoming sometimes a bit irrational when we talk about these new things. I just wanted also that maybe more a philosophical ending of my presentation. Don't take it for granted that the artificial intelligence machine learning will solve all our issues we had so far, and with our common intelligence we were not able to solve or to address them in a different way. Thank you very much.
Thank you very much, Marc, for a very inspiring talk, giving us lots of questions for some very inspired discussions, I think, for the afternoon. Don't run away. I think there will be a lot of discussions and people coming your way. So before we go into the final session of the afternoon, we will move into what many of you who've been involved in standards working groups know to be one of the most important parts in some of the working group discussions, which is coffee breaks. So the courtesy of Frequentis, thank you very much for sponsoring our coffee break today. Please enjoy, be back we're a little bit after time, but be back at 15:45 here in the room for the last 2 sessions of the day. Enjoy.